In this video, I'd like to show an example of Bayes' theorem problem using probability tree. Bayes' theorem is a way to find true probabilities associated with screen tests, such as the probability of having disease given a positive screen test result. There are two versions of Bayes' formulas, but we still can use the regular conditional probability formula shown below. I am showing A as a past event and B as a present event. The numerator has a joint probability of the two events. The order does not matter. The denominator must be event B, which is on the right side of the vertical line of the notation. Let's look at a problem. We will answer these two questions by creating a probability tree diagram first. This 82% is called the true positive rate or sensitivity, and the 94% is called the true negative rate or specificity. Before reading each question, we'll start by constructing a probability tree for this question. Here's a template of a probability tree that we'll use. These are two levels and each has two branches. The first level should be the past event and the second level is present event. There are two different events in this question. One is whether an individual has cancer or not, and the other is test result. Since the first level is the past event, it should be cancer or not. The second level is therefore the test result, which is either positive or negative for each cancer case or not. Now we can see 3% values in the question. We now need to fill each probability in proper branch. Let's start with the first percent value 5%. The question says the cancer rate in the population is 5%, so we place 0.05 on the branch of cancer. For the second number, 82%, it is a positive rate coming from the confirmed cancer cases, so place 0.82 on the branch. For the last percent value of 94%, since it is a negative rate coming from free of cancer cases, place 0.94 on the branch. Once we place the given three probability values on the proper branches, fill in the other values on the remaining three branches. Since the sum of the probabilities for any set of branches is always 1, the probability of no cancer cases must be 95% or 0.95. In the same manner, place 0.18 on the branch and it is false negative rate. Likewise, place 0.06 on the branch and it is false positive rate. Then let's find out the joint probabilities next. Now let's find out the joint probability for each outcome. The probability of cancer and positive rate is 0.05 times 0.82 to get 0.041. Here's one version of the Bayes formula. As you can see, we are using the top part of the formula to calculate joint probabilities. In the same manner, the probability of cancer and a negative result is 0.009. Likewise, the probability of no cancer and a positive result is 0.95 times 0.06 to get 0.057. Lastly, the probability of no cancer and the negative result is 0.893. Again, please make sure the total probability is 1. Now that we have all joint probabilities and their total is 1, we should use those values to answer any sub-questions A, B, C, and so on. Please do not use other probability values on branches, since the total of those values is 3, not 1. For question A, the keyword "given that" indicate the conditional probability. Let's pull out the formula. First, write the probability notation as the question stated. Make sure to place the event on the right side of the keyword of "given that" to be right of the vertical line in the formula. Place positive in this case. Therefore, cancer C should be on the left side of the vertical line. Apply the conditional formula for this question to get the joint probability of C and positive on the numerator, and place the probability of positive on the denominator. For the joint of cancer and positive, we have already calculated as 0.041 in the tree diagram. Place a value on the numerator. For the marginal probability of positive result, we can see two positive situations regardless of cancer in the tree diagram. So add these two cases and place them on the denominator. We can always see a common value on top and the bottom. Simplify the denominator to get 0.098. So the final answer is rounded to 0.418. There is a 41.8% chance we have cancer if we get a positive result. Let's try the similar question B. The keyword in this question is if, which indicates a conditional probability as well. Let's use the formula. First, write the probability notation as the question stated. Make sure to place the event just after the keyword of if on the right side of the vertical line in the formula. In this case, the negative should be on the right side of the vertical line. Therefore, cancer C should be on the left side of the vertical line. Apply the conditional formula for this question to get the joint probability of C and negative on the numerator, and place the probability of negative on the denominator. For the joint of cancer and negative, we have already calculated at 0.009 in the tree diagram. Place a value on the numerator. For the marginal probability of negative result, we can see two negative situations regardless of cancer in the tree diagram. So add those two cases and place them on the denominator. Again, we always see the common value on top and the bottom. Simplify the denominator to get 0.902. So the final answer is rounded to 0.010. There is a small chance of 1% that we have cancer even we get the negative result. I hope you are comfortable on solving Bayes' theorem questions by making use of a probability tree. Thank you for watching. See you again.